The language of algebra and expressions. This topic right here is such a big deal in algebra, and it's something that you really need to grasp. So I'm hoping that you'll watch this video over and over again to try to see what I'm talking about as far as what expressions mean and what variables are and things like that. Okay, so whenever I talk about a variable is a quantity whose value may change. A constant is a quantity whose value always stays the same. When we talk about variables, we typically use letters. X is a usual variable that we use, Y, Z, anything that we could use to mean something that could change. We could even use, in first grade, your teachers used to put boxes. Box plus 1 equals 5, and you knew that what went in that box was the number 4, right? So the same thing goes today. We're just a little bit older. We don't really use the boxes anymore, so we would say x plus 1 equals 5. It doesn't really change the fact that x is still 4, but just how we write it has changed. Okay, so these are some typical operations and words that we use for those operations. So for addition, we typically use the word sum. For multiplication, you're going to see all different kinds of notation here. I don't usually like to use the little dot in between so that you don't get confused with a decimal point, but I do use the parentheses a lot. And then it's pronounced like that, or you could say that. The result is your product. So multiplication and product go together. Subtraction, the word difference means subtraction. Division, and we use the word quotient for division. These vocabulary words are very, very important for you to understand. Okay, so in algebra, we tend to get away from using the x for multiplication because now, just like I said earlier, now we're using x to stand for a variable. So instead of writing 5 times 4, now because we're working more in algebra, we want to say 5 times 4 using parentheses. You could do 2 parentheses there. That means multiplication, but we typically get away from using this x right here for multiplication, just because now x means a variable. Okay, so let's translate from algebra to words. So on this first one, there's lots of ways to say this, so please don't think that just because I say it one way that is the only correct way. That's not so. This I would say the sum of 12 and 14. That's one way to say it. You could say 12 added to 14. On part B, I could say the product of 30 and 5. On part C, I could say the quotient of 64 and 8. And keep in mind, there's other ways to say this too. So on part C, I could have said 64 divided by 8. The quotient of 64 and 8 just sounds a little more proper. On part D, I could say the difference of x and y. Notice, we don't know what x and y are, but we just know that they are variables. They do stand for something. We don't know what it is right now, but we can say the difference of x and y here. Okay, here's some more vocabulary. Algebraic notation is really the shorthand version, A equals B. These are the words that you would say. So I'm going to give you just a second to take a look at this page, and then we're going to move on. Okay, so for problems like these where we're translating from algebra to words, it's really important that you use the word is. 20 less than 40 means 40 minus 20, but if you say 20 is less than 40, then you have to use an inequality symbol, like this one on part A. This you would say as 20 is less than or equal to 35. Notice how there's a slash through that equal symbol on part B. So you would say 11 is not equal to the difference of 15 and 3. Okay, on the next one, I would say 9 is greater than 10 divided by 2. And on this last one, I would say the sum of x and 2 is less than 10. Okay, so in this problem, we are comparing the fuel economy in miles per gallon of several cars. So you'll see that the Prius has a miles per gallon fuel economy of 48 miles per gallon. A Mini Cooper has a fuel economy of 27 miles per gallon. Toyota Corolla has 28. Versa has 26. Honda Fit has 27. So what we're going to do is we're going to compare, and we're going to put the equal to, less than, or greater than symbol in to compare their fuel economies. So the MPG of a Prius, so the Prius is 48. The Mini Cooper is 27. The Prius is larger, so we put the bigger side opening to the larger number. The Versa is 26. And the Fit is 27. So I would put the open side facing towards the larger number. So I put the less than symbol in there. The Mini Cooper is 27. The Fit is 27. These guys are equal to each other. Now I've got the Corolla is 28. The Versa is 26. So the 28 is larger. The Corolla 28. The Prius 48. So the 48 is larger, so I would do a less than symbol there. Okay, so now we're going to identify some expressions. Right here, reading this first one, you could say 3 plus 5. You could also say the sum of 3 and 5. On the next one, notice we have a minus sign there, so you could say n minus 1, or you could say the difference of n and 1. Right here, we're not using an x for multiplication, but still the dot represents multiplication. 6 times 7, or the product of 6 and 7. And look at this one, we're using the fraction bar for division. X divided by y, or the quotient of x and y. Okay, this page is just a little bit different than the last one. I want you to notice that on every single one of these we have an equal symbol. That means that these problems right here are equations. If it has an equal sign, it is an equation. So on this top one, the sum of 3 and 5 is equal to, notice that right there, 8. The next one, n minus 1 equals, notice they didn't say is equal to, but they do say equals 14. On the next one, they're using is equal to. The next one is equal to. So anytime you see the equals, you should slap an equal sign in that position. So this page is pretty important. It says an expression is a number, a variable, or a combination of numbers and variables and operation symbols. An equation is made up of two expressions connected by an equal sign. In other words, an expression looks like this. An equation looks like this. Notice the difference, that thing right there. So an equation has an expression connected by your equal sign. Okay, so let's take a look at this one. We are going to determine if it's an expression or an equation. This top one, A, has an equal sign, so we would say that it is an equation. The next one, I don't see an equal sign in it, so we're going to call that an expression. Next one, again, no equal sign, so it's going to be an expression. This last one does have an equal sign, so it is an equation. Okay, so it's kind of important that you read through this page, so I am going to give you a little bit of an opportunity to read through this, and then we're going to talk about exponents. Okay, so whenever we talk about exponents, we call the big number that is at the bottom, we call it our base. This is your base. And our little subscript, or superscript, I guess we'd call it, up there at the top is our exponent. And what this means is I have 5 multiplied by itself 3 times. So 5 times 5 times 5, which, guys, is not 15. It is 125. 5 times 5 is 25. 25 times 5 is 125. So be real careful about that. That is a common mistake that people do, is they want to multiply the base times the exponent, and that is not so. We do have special names for whenever we have 2 or 3 in the exponent. You don't have to say that. A to the second power can be read as a to the second power, or it could be read as a squared. A to the third power can be read as a to the third power or a cubed. Okay, so let's write these in exponential form. I've got 1, 2, 3, 4, 5, 6, 7 16s here. So to write this in exponential form, I would say 16 to the 7th power. I'm not going to multiply that out. That's going to take me a while, and I'm not sure my calculator can do that. Alright, so 9 times 9 times 9 times 9 times 9, there's 1, 2, 3, 4, 5. So that would be 9 to the 5th power. 1, 2, 3, 4 x's, x to the 4th power. Got 1, 2, 3, 4, 5, 6, 7, 8. 8 a's, so that's a to the 8th power here. Order of operations is kind of what makes our math the same as math even in China or Russia or any other country. Everybody follows these rules of order of operations. That's why our calculators work the way they do, and that's why sometimes we don't get the same answer on paper that we do whenever we type it into the calculator, because on paper we may not have followed the order of operations. And most calculators nowadays do, not all, so you have to be careful, and you have to know if your calculator is the kind that understands order of operations. The TI-30XS and the TI-30X2S calculators do understand order of operations because they have the display line. So you type in the whole problem, you hit enter, and then it gives you the answer. On calculators where you can only type in one number at a time and you hit an operation in between the numbers and the line goes away, then those types of calculators do not understand order of operations. With order of operations, though, the first thing that you're ever going to want to do is your parentheses or any other grouping symbols. Grouping symbols could be parentheses, they could be brackets, they could be the little squiggly brackets. It also could be absolute value symbols. Those are all considered grouping symbols. And it says that you should simplify all expressions inside the parentheses or other grouping symbols, working on the innermost parentheses or grouping symbols first. The next thing that you would want to do is your exponents. Exponents are what we just talked about with the base and the exponent. Do those next. On the next order of operation, multiplication and division. Notice these are listed together, and it's important that you do them in order from left to right. If you do not perform your multiplication and division in order from left to right, I promise you, you're going to get the wrong answer. The last thing that you're going to do is addition and subtraction. Perform all addition and subtraction in order from left to right. Okay, so let's practice that. Here's a cute little sign. You'll see this a lot whenever we're talking about order of operations. Please excuse my dear Aunt Sally. The P is your parentheses, the E is for exponents, my dear, multiplication and division, and Aunt Sally is addition and subtraction. Okay, so using the order of operations, this expression right here on part A has two operations in it. It's got plus and it's got multiplication. According to the order of operations, you have to do your multiplication first. So I'm just going to rewrite this. 4 plus 3 times 7 is 21. 4 plus 21 is 25. Notice I'm using the same numbers on part B, but what I did is I added some grouping symbols here. So look at what the grouping symbols do to our answer. The grouping symbols, remember please, the parentheses, we have to do that first. So 4 plus 3 is 7 times 7, and then you multiply those guys together and you get 49. So our number did change because we added grouping symbols to this problem. Okay, according to the order of operations, we need to be doing this first. So I just rewrite everything else. 18 divided by 6 plus 4, and then in parentheses now I've got 5 minus 2, which is 3. According to the order of operations, I now have to do, because what I have left over is division, addition, and multiplication. That 4 times 3 means multiplication there. I've got to do my multiplication and division in order from left to right. So 18 divided by 6 is going to be 3 plus 4 times 3. I could have done that in the same step, but I don't want to confuse anybody. Now I'm going to do 4 times 3, 3 plus 12. Now I'm going to do my addition, and I get 15.